Hello, my name is Michael Ivy, and today I will be discussing lead pollution in Kabwe, Zambia. To begin, I will start with a brief overview of Kabwe, Zambia. I will try to explain and understand lead poisoning, and I will try to show a correlation between the lead industry of Kabwe, Zambia and the negative health outcomes of the surrounding townships. Kabwe, which means ore or smelting, is the capital of the Zambian Central Province. The long history of lead mining has resulted in serious environmental and health-related issues. Lead is a heavy metal which can adversely affect the circulatory and nervous systems. Lead poisoning is particularly detrimental to children as it can reduce cognitive ability and cause developmental disorders, thus negatively impacting future health outcomes. As stated, Kabwe has a long history of lead mining, which has resulted in highly contaminated soil. Subsequently, children from the surrounding townships have shown high levels of lead in their blood. This town serves as an example of lead pollution and the need for regulation and environmental awareness. Here is a table of contents. My first slide will show the geographic distribution of estimated blood lead levels. For both children and adults, blood lead levels were high in the west by northwest and east by southeast regions of the Black Mountain dumping site. Blood lead levels greater than 45 micrograms per deciliter were found in the neighborhoods of the mine waste dumping site. These blood lead levels tended to decrease with distance. However, the blood lead levels of children exceeded 5 micrograms per deciliter throughout most areas. This geographic distribution is likely caused by the transportation of mining materials, particularly slag dust containing lead, which is transported by air and waterways. The local climate and airways have caused much of this distribution. Here, I have provided data from a study focused on blood samples that were collected from a total number of 1,190 household members, including 291 younger children, 271 older children, 412 mothers, and 216 fathers. Of the 1,190 participants, 30% had blood lead levels below 5 micrograms per deciliter, which is the level of concern. Of the total number of children sampled, 562, a total of 130 or 23% exceeded the 45 microgram per deciliter, the threshold required for chelation therapy. A few children, a total of 5, exceeded the 100 microgram per deciliter, or potentially fatal blood lead levels. According to the CDC, 5 micrograms per deciliter is used as a reference level for lead poisoning, and chelation therapy is recommended for those with blood lead levels above 45 microgram per deciliter. This graph shows the percentage of these blood lead levels across various risk groups. All groups showed elevated levels, with the highest being 6 to 10 years of age. This may be the case because those in this age group observe certain factors which put them at greater risk. This age group, 6 to 10 years of age, is younger children, which tend to play within the lead contaminated soils. Blood lead levels of children under the age of 7 years were taken from townships neighboring the mine. All of the sampled children had elevated levels exceeding 5 micrograms per deciliter. Children in these areas could be at serious risk of lead toxicity, as 18% of the sampled children in Chawa, 57% in Kasanda, and 25% in Makalulu had blood lead levels exceeding 65 micrograms per deciliter. As previously stated, medical intervention is recommended at levels exceeding 45 micrograms per deciliter. Here is a table from a program designed to reduce blood lead levels. According to a December 2012 report by the company providing the program had resulted in a reduction of blood lead levels in 2,822 children out of 5,000 children tested, of between 20 to 25% in the case of treatment with nutritional supplements, and by up to 74% for children with blood lead levels beyond 65 micrograms per deciliter who were given chelation therapy. While the program had struggled to find funding as of 2012, recently the program has had continued funding for lead mitigation therapy. As such, an additional 2,657 children have been newly recruited into the program, and 1,598 children have been retested since the project closure. Moreover, new data confirms that the blood lead levels in affected communities continues to decrease. From 2010 to 2012, the geometric mean of blood lead levels fell from 30.1 to 26.3 micrograms per deciliter in the affected communities, and the downward trend in blood lead levels was observed in 6 out of 8 of the affected communities. In summary, Kabwe has a long history of lead mining. As such, there is a direct relationship between the blood lead levels and the distance from the major lead mining site. Blood lead levels appear to be highest amongst children ages 6 through 10, likely due to the particular factors of this age group, such as playing in lead-contaminated soils. Children at risk of lead poisoning came from townships adjacent to the mine, and lead contamination mitigation programs appear to be successful. However, elevated blood lead levels continue to be a serious issue. Here are the references, and thank you so much.